Oh, hello everyone. Today we'll be seeing. I hope you're doing great, first of all, and we're going to see project planning and EDA analysis. Those two concepts are a little bit different, but we're going to see how to plan the projects related with an academy. It might be projects related to the projects that we're doing now, or it might be other projects. Generally, the concept of project planning and also EDA analysis, which is we're given a data on this week challenge, and we're going to see how to clean, how to analyze, not to analyze actually, how to observe and how to understand the data in a form of EDA. So let's start. So what is project planning? In a concept wise, I think everyone is somehow familiar with the definition, and it kind of seems easy, right? But sometimes while planning projects and while trying to do projects, we need to be more careful or more detailed in order to know every steps, and in order to have a good result or um, output from the project. So generally it's a systematic process of before that, I think there's some voice. If there's, yeah, rough, is that from you? Sorry.
No, no.
Okay, there's a background sound. If there's anyone who, yeah, okay. So, and outlining the task, resources, timeline, and deliverables required to achieve specific project objectives. So, while we are speaking about project, there's an objective in that is going to be achieved at the final result, right? So, we should control, or we should see whether we can achieve the objective or not, or the goal or not, depending on our budget, scope, and time. So there are some key components of project planning. Therefore, I had just put it down in a bullet point, and we will just go through them, or go through the definition. So there's the scope definition first. It might also seem easy, the scope of a project, or putting the scope of a project. Like, we might assume that, of course, it's our project, or and we are sure on how deep are we going to do. So we're not supposed to put the scope specifically, but no, we should put the scope specifically, because you never know when you're going to be out of the line, or when you're going to be too when you're not going to be that deep in order to achieve the goal. So you might not be able to achieve the goal due to wide scope or very narrow scope. So we should define the scope. From what to what level am I going to cover this project? What is the aim, and which part is not going to be included, or which part is going to be excluded in my overview? So the first one is to define our scope, and then there's the work breakdown structure. So there are different steps in order to achieve some goal, or in order to finish some project. There are going to be many works to be done. So, and traditionally, people will just start working, or start working on the project from the first step, or from the beginning, from what it seems like the beginning step, and just go with the flow. So, and that is not the right thing to do. So we should break down the work, and we should know every details that is supposed to be, or that is going to be done while doing the projects. And there's the timeline and milestone. So now we've just break down the project, right, or the structure. So in what timeline are we going to achieve those specific tasks, and what is the milestone while doing those tasks? So by milestone, we mean what is the specific thing that we're going to achieve from one of the breakdown task. So we're going to break down the structure or tasks, and we're going to put timeline in, during what duration, or during what timeline are we going to finish those tasks. And there's the resource planning. In order to achieve that work in the specified timeline, we need to have resource, right? So what amount of resource do I have, and is that enough to achieve the specified tasks? So in resource, we mean budget wise, human resource. It might be office, it might like everything, every resource thing, you know that is related, everything that is needed to achieve some project is called as a resource. And then there's a risk management, which is There's always a risk. We can put some direct risks, or also there are some indirect risks that might happen, or some unseen risks. So we need to put we need to put or define or have a guideline in how to solve those risks, or how to overcome those problems or challenge if one of them, if we're going to face one of them. And for sure, mostly people always face some, face some risks, and we're supposed to put management risk management guidelines. And there are tools and techniques. Also, what type of techniques am I supposed to do in order to accomplish the project, and what tools do I have in my hand, or can I use from the internet and from everywhere. So what type of work is supposed to be done, and like, depending on the work, we're going to search what type of tool should I use. There is the roles and responsibilities. So we need to have, or we need to specify a role and responsibility for every, like, let it be even two team members, and even let it be you and like one. I mean, minimum you can be one, right? While accomplishing a project. So you need to have roles and responsibilities stated. So like the roles, let's say the roles alone. The roles, if you're going to assign some role for a specified person, then that person is going to be responsible for that task. So you know where to go, who to ask about that issue, and also who to make responsible for that if it is not done, or if it is done wrongly. So it's also an important aspect. And there's the budgeting and cost management. Of course, this is also one of the important things, especially uh, things. There are a lot of things which involve money and cost. So this also related. There's after finishing the project, we can say that after coming to some final level, where there's the monitoring and evaluation. How is I mean how is the project done? Is there any error while doing the project, or anything that might result on the wrong results of the project? And evaluating the whole process, there is the documentation and reporting. So almost all projects, from the beginning to the end, they need to be documented and they need to be reported, documented and put it for for future use, for insights and for experience, and reported for the specific, or for the concerned people. If it is a project for a company, then for the company. So maybe if it is a project that is looking for some investors, or like pitch deck, so you need to report your project for investors. So at the end of the day, it need to be reported. And there's the lessons learned and continuous improvement. Um, in the conclusion, what I really need to add on this is, let's somehow relate this concept with our project. There are some there is a reporting at the end of uh, finalizing a project, right, through the week. So I say that in the reporting section, don't forget to include, or on the documentation or in reporting section, don't forget to include the lesson learned from the whole project or the process. What have you learned from doing this project? If it is um, like, what are the specific things that you've learned, and also there should be, or there's of course a part that you need to improve, or that you're not able to finish during those 1 weeks. If you're somehow confused, I'm talking about the 10 academies project, right? So if there is, you need to put the lesson learned and also the continuous improvement. I mean, what is your insight? What can you improve? If you have time more than 1 week, what things could have you improved, or uh, like, go deeply and do it in a better way. So, and also there's a conclusion, of course. So don't forget this part to include on your report, in your 10 academy project report. And but the whole concept is about just every project planning. You can relate some of them with your projects. And not everything should be taken for every project. It depends on the project, what type of project, and for who it is being reported. So you can take most of those concepts or components for your 10 academy project reports, documentation and reports. Um, so now let's get into the EDA analysis. What is EDA? EDA, actually, there's some piece that is not mentioned here. So EDA is exploratory data analysis. So there's a difference. I'm sure that you have heard about data analysis, but what is the difference between EDA and just data analysis? We're going to see that, and just let's introduce ourselves with EDA. So we have a data. So now I want you to put yourself out of the project planning part, and we are on the EDA part. So now we're going to be talking about the datas. Um, so on this week's challenge, you have a data, right? There's a data of solar radiation from different African countries, right? So we have a data. So what is the first question? What can we generate, or how can we generate meaningful and useful information from a data? So those data are put it there in order for us to see, observe, analyze, and finally observe some useful information. So what is EDA? EDA, or exploratory data analysis, it's examining the available data set to discover patterns, spot anomalies, test hypotheses, check assumptions using statistical measures. So what is the main thing is it is somehow tedious. Actually, it's not somehow, it's absolutely tedious and tiresome to check, to go over data just by seeing them and trying to say, oh, this data like is indicating me that this kinds of things, I am having this kind of insight from this data, right? So it's tedious. So what is the point of EDA is, what the point of EDA is to discover patterns, what kind of data, I mean, patterns do those data, or do those parameters have, mm, and what can we say about this situation? What can we say about the solar radiation depending on this data? So I hope you got the idea. So EDA is to examine the data, like to know the patterns of the data, to know if the data is clean, if the data needs improvement or something. So EDA and data analysis are not the same concept. So what is the difference? Data analysis at the end will try to put some not hypothesis, recommendation or insights based on the data. We're going to give some conclusion by analyzing and going through the data. But EDA, it's just about the data. It is just concerned about the data itself. What is the pattern? What is the relation? So it's at the end, we're going to have, at the end of an EDA, we're going to have a data that is prepared and that is well put in order to make a data analysis. So I hope you got the point. And today we're going to see the EDA part. So the first step in EDA is data collection and understanding, but in your case, and in most cases, maybe the data are going to be provided. As you know, collecting data is not an easy task. So it's included in the EDA process, but here we're not going to include it. But as a general concept, we gather and explore relevant data source, focusing on understanding the dataset structure, variable, initial insights to guide our analysis. So let's get to the data cleaning and pre-processing part, which is the second part. So when we mean what do we mean by pre-processing? It's exporting the data set from where the data is collected or from where the data is placed, and place them under the right table, structuring them and export them to the correct format. So what depends on what type of format do we need in order to make our EDA. So it's just pre-processing the data for the EDA. And then there's the data cleaning, of course, which is a very one of the important part of the EDA. So like there might be incomplete data. I mean, there might be some data with null values, which are empty, because there are a very large amount of data. The data collectors themselves might miss some points, actually not some, but many points. So we're going to check whether there's an incomplete tables, rows, and or items, and duplicate checks. So those are errors that could happen in data collection part. There might be duplicated items, or one parameters, or one row put it 2 or 3 times. And we're going to check for the error. We're going to check for the missing value, dealing with outliers. Outliers, like we mean, there are, for example, let's say we're trying to evaluate, or we're trying to analyze students' results in specific subject, and maybe one student have, so most of the students have like 50, 40, like those, or 60, those kinds of grade from 100, and one student might have 0, the other might have 100. So it is really out of the line, right? It's going to affect the data in, it's not, if those types of data are small, actually 1 or 2, it might not have that effect. But if it is kind of not that large, but large from 0 and 1, it's going to be an outlier data or another data that doesn't really tell the real situation of the student or the data search that we're making the data analysis, or the part that we're making the data analysis on. So we're going to deal with outliers. So the data cleaning part is very important. So just don't forget the concepts, and don't forget to, and you will see, or you try to see by yourself, how to interpret those by codes. So how to check for incomplete, how to check for outliers. There's also in your you can check on your technical document. So first we need to go to with the data clearing part. After that, we're going to make analysis. So in a data, there are different parameters, right? um, so by parameters, you know what I mean. I think you have just saw the data of the solar radiation. So there are different, the temperature, so different parameters. So univariate, and when we say, there's also here the bivariate and multivariate analysis. When we say the bivariate analysis, it's about analyzing the variables alone. So univariate is just analyzing one variable alone. It's simplest form of data analysis, where the data being analyzed consists of just one variable. Since it's a single variable, it doesn't deal with cause or relationship. So the main purpose of univariate analysis is to describe the data and find pattern that exists within it. So what is uh, so afterwards, let's go the part that we're making. If it is the student, Mr. X, um, like, let's just call the parts that we're making the data analysis as X. So when I just say X, I'm referring for the part for the switch. In this case, for example, the solar radiation, let's just say it X. So X is going to have, we're going to analyze just one parameters, one parameter of X, one parameter of solar radiation in univariate analysis. So it is just simple. We can use the histogram, the bar plot, the pie chart. So if you can see this graph, there is the count, male and female. So if you just can see the codes here, maybe you cannot see it very much, but so the point is that there is a parameter called male. So we're going to just we're just seeing the male part, and here we're just seeing the female part independently. So we're just analyzing this variable alone and this variable alone. So in this case, it's called univariate analysis. Let's see the bivariate analysis. So if uni is 1, then yeah, bi is 2. So here we're analyzing two variables together, which means there's a parameter called department name. While analyzing again an X situation, there's a parameter called department name and length of service. So we are trying to analyze those two parameters with each other. So what is the length of service depending on the department name? So this is the analysis that we're trying to do, which is called bivariate analysis. So like, I think uni and bivariate analysis are clear, which is multi means more than two. So multivariate data arises from more than one variables. Actually, bivariate analysis are also considered as multi. So multivariate non-graphic. Okay, there is two types of analysis. One of them is non-graphical, but mostly we're going to use the graphical one in trying to analyze the data. It's going to be good to analyze them using graphical form. Generally shows the relationship between two or more variables of the data through across tabulation or statistics, or just like here we're seeing two parameters. So here we're seeing uh, individual parameters on univariate, right? So when it comes to multivariate, we're going to see many of these many of these parameters together in respect to one count or one analysis. So they're not individual. We're going to compare each parameters or more than two parameters with each other. And let's see the visualization techniques. So visualization techniques is, in what form should we see the graphs? So just we have just mentioned that it is good to do the analysis, actually both the multi, the pi, the uni analysis in a graphical way. So do we have a visualization techniques in Python? So most of you know that there is those libraries that are used for visualization techniques. So we mostly use the Matplotlib and the Seaborn for the visualization techniques. So Seaborn, it's built-in, and Matplotlib is the widely used Python library for creating static, interactive, and application quality visualization. And Seaborn, it's also built on top of Matplotlib. It offers a high level interface for creating attractive statistical graphics. So most of the time we're going to use Seaborn if while doing those multivariate or bivariate analysis. For just drawing a graph, we simply can use Matplotlib library. So this is it about the presentation. So I just heard yesterday, whilst it was I think some questions about Anaconda or something were being asked. So we can see somehow let's see how to start. Mostly we're going to use Jupyter Notebook for the I mean for the EDA. And so let's just see some concepts there. Wait, sorry, I'll be back. The whole screen اللي اسمه بشير ميتر. So let's get back to for people who were asking about Anaconda. Anaconda, it's just an IDE, as just Kerud mentioned yesterday. You can install it from your Google. Okay, is there any question? Hmm? When will be the slides ready? When will be the slides be uploaded on the project? Do you mean anonymous synonyms? Okay, so like the slides are going to be uploaded after the presentation had ended or after we finish the session. So let's just see. So Anaconda is just um this is the platform. Like you can see my screen, right? So this is the interface of Anaconda. You can just download it from Google, and there are two anacondas, the mini anaconda and anaconda. So I recommend if you can use the just anaconda rather than the mini. So what is the main idea? It's a good IDE for data analysis or something. So you can get VS Code and both Jupyter here. So you can just launch Jupyter, which is going to be launched in your in some browsers on your default browser. In my case, my default browser is H. So it will open this, or let me say back. It will open the desktop. So you can create on your desktop, you can create a file or a folder for your EDA analysis. For example, let's say that you just named it EDA, and then inside that you can just come here and new Python 3. You can choose this one, and you can get a new notebook. Then we can make our data analysis here. I mean, our EDA here. So what is the good part? Actually, VS Code also can integrate notebook. So what is the good part of notebook? It's we can just see the output of our data uh, here. Like it's a very good tool for analyzing, to see the data, to be interactive with the data, to change our mind, and to see some insights from the data. So of course we're going to import some libraries. Those are it's a good recommendation just to import every library that might help you. So it's not a must that you need to import a specific or two or three libraries. So probably we're going to use those libraries, pandas, matplotlib, and seaborn that we've seen before. And after importing that, on this case, it's just I'm going to just try to demonstrate the concept. You're going to go deeply through it, and on this case, I'm going to use the iris dataset, which are it's the famous dataset. I had just downloaded it from one of the here, I guess. Yeah, UCV Irving. Actually, you are provided with the data, so you don't need to worry about downloading or bringing the data. So I just put the data inside here, iris.csv, so that I can access it or find it easily. So the data, I just read the data from this folder as data. So this, the variable called data, holds the iris file, which means, so let's see the structure of the data. It's just like this, right? It's not even put it in a column shape, so it's random data dot. We can just see the first 5 data from our data file, and the shape of our data is 149 to 1, so which means we have 149 number of data. But if you can see that there is 5.1, 3.5, 1.4. If you have an idea about iris dataset, it's like the petal links, the petal width, it's about plants, right? So the data are so here it's just how they're put it: 5.1, 3.5, 1.4, 0.2. Those were supposed to be a column, and there's the data. Those are the data below those columns. So it's just, but now it's considering all those data as a one column. So yeah, we're going to be back for the description. So we need to change the column, right, in order to make an analysis. For example, let's say if we know, or that's why in data pre-processing, or in understand, we need to understand the data first. So understanding the data, understanding all the parameters, we just can give whatever name we want for all columns and rearrange the data again. For example, here we just put column 1, column 2, column 3, column 4, and column 5. Since if you see here, there is 5.1, 3.5, 1.4, 0.2, and I reset also as different columns, so they are 5 in total. So we just need to have 5 columns. This is really not the type of data, I mean column name that you should give, but so this is a demonstration. We can give that, but you will give a column name related with the characteristics or with the behavior of the data. So so we just, yeah, after that, I mean, this line, we just renamed the columns, and we've just dropped the data, which just included all of them together as a one. If this data actually, let's see, if this data were not included, so this part was also included as the first column. One of the actually one of the disadvantage of notebook is we should run from the beginning while we add, or we made some changes. So oh, sorry, like, so I wanted to show you, like, if we just delete this part. So you've seen that the first row is like this, right? And now it's just named as column 1 and something. But now I have deleted one line of code. And when I just say data dot hit, it's going to include this line here. So by this code here, we just removed or dropped the first column of the data. So now, yeah, the first column is removed. This is the structure of the data, or the structure of the data that we want to have. While describing the data, actually in describe we can get the mean, the standard deviation, and other data. But depending on the data, here we just have count, unique, top, and frequency. So it's going to here is the value of the counted columns, unique values, top 5 values, frequencies, or like. mm, there is a on column 1 there are 10 data with somehow same 10 place data with somehow same value. So we can just describe and go over. Actually it will be more important if we had included the mean and the standard deviation types of values in order for you to analyze the data. So we can see the columns here. Mm, so in this part also, okay, so if you've seen here the data type is object, so it could have been integer, float, right? But there's some values called arrays vector, which are not numerical value. There are some numerical values. So if the mixture of those types of data, or the data that cannot be specified as whether an integer, a float, or just a string. They're called objects. And so now we're trying to see on column 5. On column 5, if you've seen, there is the iris setosa, so it's kind of some wordings, right? So we're trying to see what kind of variation. I mean, what could it be? What could the column 5 could be? If it is not iris setosa, it is the iris. Okay, I might not pronounce it right. So those are the possibility of the column 5 could be. It's whether iris this, whether iris this, or whether iris this one. So we can just check the values included, or the type of yeah, actually the values included on the specific column on this way. So we've tried for column 4 also. It's just an integer, so it just mentioned most of the integers mentioned there. It's wide actually. It's this one is not useful, but if it is specified like 4 or 5, if the data is one of the 4 or 5 values, so we're going to see the, we can check what type of value do all those data have using this. And also so like, while what did we mention before is while cleaning the data, we need to make sure one of the method is if we have null values, or if there is a value with no value. Actually, if there's a data with no value, we need to make sure that, right? So if there's much of that, I mean, if there is, for example, if there's a column with uh, having null values more than 50%, then that column is not going to be that useful. Maybe it's going to be actually unuseful. I mean, making our analysis, or taking our analysis for with the wrong direction. So we need to see if there are many missing values or not. So here we are just checking for values or null values. So it is, if you can see that, it's called false false false, which means there is no null value. I mean, we're dealing with some values, I mean clean value or clean data here, but this is not going to be the case with you, I think, because it's just a very wide data that you have. You're going to have some null values or errors and those kinds of things. So we can also make this mm, yeah, so this might be, there are some jump rows over here, so but it would be better this way. So this one, or the second line of code, is going to tell us if there is a null value in the column 1. No, there's no null value in all columns. Column 1 to 5, there is no null values, which is okay. We can just say that, oh, the data is clean. But if not, you should make some analysis, or you need to clean the data. Not analysis, sorry, you need to clean the data. So let's say that it's not actually the column in 1, 2, 3, both are I mean have no null values, but let's say they were having much or many null values. What are we going to do? It's we're going to drop the data, or let's see this first. Let's say the data, in order to get the data cleaned, we can just put some thresholds. So threshold is the length of the data times 0.5, which means we're going to drop columns with having more than 50% null values. It's indicated on the comment here. So we can use just here, we can use this analysis first. If we have just seen more wrong data, we can just proceed to dropping that column, or if it is somehow tiresome to just again tiresome to see those columns and to just go over every data by yourself, we're going to put some code to solve that. We're going to put that some variables, and if if that is if they are those if they reach that threshold value, if the more than 50% of that column is null, then we're going to drop that column, and we can use this code also. But in this case, we can't use it because, as I told you, it's um, it's a data with no null value. So, for example, let's try dropping column 1 and column 2 here, and the result you're seeing here, it just drops column 1 and column 2. So the new structure, or the new data structure, if column 1 or column 2 were unclean, or you know, wrong or disadvantageous column. So we would have said that the new cleaned data will be this, but actually uh, both this and that data is clean. So let's just see how we can do univariant analysis. And so here you can see, uh, so now our data are column 3, column 4, right? Now we're trying to draw column 3 first. Here we're going to draw column 3 and column 4 in together in one axis. So we're in like one axis and two rows. Yeah, I mean one row and two column. So here is the column 3 figure and here is the column 4 figure. You can just see that there's a data over here, okay? So column, we've just used the histogram on this part. As I told you on the presentation, you can use whether pie chart, bar chart, whatever you want. So, but this is the concept of drawing the univariant analysis. We're going to analyze only column 3 here and only column 4 here. And what about multivariant? So here we're going to, as I told you before, so in this case, we're trying to analyze more than two, more than two, more than two columns, which is multivariate analysis. So in this case, we're drawing three, since we're comparing three variables, we're going to draw three rows. I mean, one row and three columns. So let's see which parameters will be included. Not parameters, sorry for the mistake. Columns. Which columns are being compared? Here we're comparing column 3 and column 4. So you can see the data. I mean the graph, column 3 and column 4, and then there's the column 3 and column 5, and column 4 and column 4 and column 5. So what is the knowledge? What is the idea? We're seeing all the three. We're comparing all the three data with each other. One column 3 with 4, column 3 with 5, and we're seeing the output in one line, and so that we can see the relationship here, and we can see, okay, column 3 is more related with column 4 than column 5. We can say that by just seeing the scattered plots over here. So this is the multivariate analysis. So you can just integrate the slides knowledge with this code, and actually you're supposed to go deeper on every analysis. You can make the graphs in pie chart. Also the scatter plot, you can change. You can use different kinds of plotting for also for the multivariant analysis. Make an analysis, and you should know how to take some insights or some knowledge from just seeing those data, and find out for another ways to make or like to make data analysis or to make graphs, to clean the data, another errors type of another another type of cleaning the data. So you need to go deeper on every aspect, but uh, this might help you to start the project. So do you have any question? Or do you have a good insight of about the presentation or the title, or you know, about EDA especially? Any reaction? Okay, okay. Have to. Thank you, guys.
I think the presentation was clear. I just have some questions.
Okay.
You said that we have to use the notebook for EDA, and for what purpose are we gonna use VS Code then?
Okay, actually, you can use, as I just said before, it's not a must to use Jupyter or VS Code. You can use whatever you want. You can also use notebooks in VS Code. It's okay. Just you can add the Jupyter Notebook extension in your VS Code, and you can use VS Code, or you can just simply use Jupyter Notebook. So Jupyter notebooks are specifically used for data analysis, data interpretation, like for data related things. So VS Code had a wide range of, actually, you can do both of them on whatever you want, but yeah, you can choose what is easy for you. You can just integrate notebook with VS Code and use VS Code, or you can just simply use the Jupyter notebook by installing Anaconda or using another method.
Okay. I just was thinking if we are gonna use the notebook on Anaconda, is it enough for the project?
Okay, I think I should get back to you after that. But for the EDA analysis, the notebook is very enough. That I can tell. I'm not sure if there's another aspects of things that you should do on the project. If that is the case, then you might should use VS Code. But still, it doesn't stop you from using the notebook for the EDA. I mean, if you're thinking about the EDA, just you can use the Jupyter notebook only. And if there's another task that you're supposed to do with VS Code, then you can add on you can do that using VS Code, and it's okay that to do them on two different platforms. Also, since I
There are
also
some additional activities that we have to done it.
yeah,
One
actually
of them
you're
is
going
unit test.
also, yeah, you're going to use Streamlit and other tasks, so it's okay to do the EDA analysis. I recommend to use to do the EDA analysis on Jupyter Notebook, and you're going to proceed for another task for for the dashboard development and other specific every task is using VS Code. It's okay to to do your project using both of the IDs.
Okay, thank you.
Okay. So, there was someone who raised their hand. Was that Anira? Okay. Where will be the okay, just Salamawit. Okay. Salamawit, you can go on.
እሺ እሺ አመሰግናለሁ። እንትን ፋይሎቹ እነዚህ ሶስቶቹ
Salam, can we make it in English? Salam. Okay. Anyone from Tin Academy team? Okay.
ልጻፍለት ሜሴጅ
How to integrate data from different CSV files. Okay, you can just Sion, you can just insert data as we now we have just inserted iris data.
Salamawit, you can continue in Amharic. It's okay.
Okay. Salam. Salamawit. So it's Sion, as I told you, the same way we have imported the iris.csv file, you can just import another data in the same way, and just you're going to give them different name. For example, we've just said this file as a data, right? And just give another variable for your newly imported data, and it's okay to proceed like that. Salamite, you can proceed. Salam, yeah.
እሺ እሺ እንትን ሶስቶቹንም ፋይል ነው የምንሰራው ወይስ አንዱን ነው? ሲኤስቪ ፋይሎቹ
ሶስቱንም ማለት
ዳታ ላይ የተሰጡ ሶስት ፋይሎች ናቸው አይደል? ሲኤስቪ ፋይሎች።
ኦኬ፣ ሶስት ዳታ ነው የተሰጣችሁ?
አዎ፣ ሶስቱንም ነው የምንሰራው ወይስ ነው?
ሰላም
ሄሮድ
ጥያቄው like the question is that you do analysis ሰርታችሁ ሪኮሜንዴሽን እንድትሰጡ ነው አይደለ? So analysis recommendation ለመስጠት ደግሞ you need to compare. So you are expected to use all three data sets and come up with a recommendation for the company. So use ሁሉንም ያው ግን አንዱን ከሰራችሁ it's easy, right? If you do just one, copy and paste like the same procedure, the same script, you can use over and over again for the ለሁለቱ. So yeah, you are expected to use all three.
Okay. So now I think it's an answer for Zion. Yeah, if you can give them different name, you can just compare them. Another question? Okay. So Okay, so there is this general concept about data analysis, right? It's about going through the data and from the beginning seeing the data, and at the end of the project or at the end of the project actually, we're going to have some insights or some output, some recommendation, some strategic goals or plans depending on the data. So the data analysis is the biggest circle or the biggest insight. So EDA is something, or it's a spot, or it's a point that is found inside data analysis. When we say EDA, we should start from how to prepare our data for that insight or for that conclusion, for that recommendation. So preparing the data, seeing the data, viewing the data, going through the data before going to the conclusion and the analysis, that is the EDA part. And finally, the big circle, or the whole circuit that includes the EDA and the conclusion, that is the data analysis part. So data analysis is the biggest picture of EDA, and EDA is a subset of data analysis. Am I clear, Daniel? Okay. Another question? So if there are no questions, this is okay. We will share you all the files, the PowerPoint, also the program, the codes. I believe we have to do both EDA and data. Of course, of course. You're going to go through the EDA before the data analysis. That is the first step to before doing the data analysis. And that's right, you're going to do both the EDA and data analysis. Another question? Okay. So I think we can. Okay. Can you also tell us about Git and GitHub? I think to understand clearly. Study lifetime exactly. Okay. So Git and GitHub, it's just okay. So while doing your programs, or while coding, or while doing some projects, you need the projects to be put it on some platforms, right? So let's just see it easily. So GitHub or Git, like GitHub, it's a space, and Git is the pushing, the pulling steps. The main name is Git. So it is just you're going to put your works or the projects that you've gone through on GitHub. So which means you're going to push them. And also after time, so if you need to access your projects, or if any other person needs to access or go through your project, they're going to push it from your GitHub, or they can just see it from your GitHub page, so that they can see what has been done, or what kind of project have you done, what kind of method have you tried to accomplish the projects and things. So GitHub, it's a page that is used to store your code, or your works, your projects, different projects. So like we're going to see, or for example in Ten Academy, we're going to check your works in GitHub. We're going to go to your GitHub account, and we're going to see whether what things have you accomplished, what things have you done. So this code, for example, we've just seen some codes here, right, in my computer. So I can just push that code in GitHub, and it's going to be presented the same way it is presented here, so that everyone can go through it and can check it. So you are going to use GitHub to put your code, and yeah, that is the main idea of GitHub. I don't specifically understand your question, Amr. Maybe you can open your mic and talk. Amr, or is he somehow clear now? So like, I think you've just go through those concepts yesterday. That is why. Mm, okay, Amr, go on.
Okay, hello. My question is on the task one, it says just Git and GitHub. There is a graph, there is a folder structure, I think. And how
Okay,
it's done, could you please clarify it?
okay. Let's go through your projects maybe.
Challenge document.
Oh yeah, I mean challenge document.
Okay.
This is not the document, right, Kira? So-
Yeah, so let me just say
Yeah.
a bit things. So yeah, as we have discussed yesterday, Git is just a VCS, like a version control system. So it just allows you to do your work anywhere with your to collaborate and just edit and access your code at any time. And GitHub is just a website or a web platform that you can interact with Git. So just you're gonna have GitHub account. I hope you already have a GitHub account, Amr. So this okay. So this folder structure is just a recommendation. So it's better if you use it. It's just a recommended structure. So you're gonna set this up on your machine and push it to your GitHub or any other way you want. So you are not limited to this folder structure. I just want to underline that, but it's just a recommended structure. Am I
Yeah.
clear, Tamer?
Just to add some things on this, Tamer. Okay, like for Tamer. So you're going to create files in your computer before pushing them to GitHub. So you're just going to create some like some files, folders, right? So this is the recommended way to create the folder. So there is the git ignore the requirements, the readme individually, but here it says in those GitHub folders you might use. So if you include the unit test or something, so just include them under the GitHub folder. Okay, so if there's a JSON file, .json file in your work, then include them under this folder. So like those arrows are just to tell you that in order to include them here, you're going to do you're going to do taste. So probably it is the name of the folder. It's going to be probably init.py. Just put it under a folder called taste. So while creating a folder in your computer or in your machine, it's preferred, or actually it's encouraged to do it in this way. It's somehow I think the folder structure is also evaluated on the evaluation part. So for all of you, it's better to follow this folder putting way. Okay. Other question? You have to.
On the structure file, I just have a question.
Okay.
Can you go there? If we are gonna use the notebooks for EDA, why are we using the source file?
The source file.
Yeah, source. There is source folder.
Yeah. Source is just a name. I mean, it's just you can name it. Okay. Most of the time, if you've gone through, you can check other GitHub profiles. So there is a branch called or like a folder called source, and under that we can include the notebooks. It's just how to name it the folder. I mean, it's not related with other things. If I get your point right. Did I? Okay. Haftom, is that clear? I mean, or you can clarify your question more. Okay.
It is clear.
Okay. So here, Salamite, you say that push any works in GitHub. How to push EDA files from notebook to GitHub? Okay, so Salamawit, can you just push another file of another type of codes? Like, how are you pushing other codes? Are you just doing them directly via VS Code, or? So the point is, you can just if you're using the Git terminal, you can just push the notebook as the same as that you're pushing the other files. It's just git push the other link. I think you've seen the Git structure. If you have missed the yesterday's class, you can just go to the YouTube channel and uh, check the sessions. Don't we need to? Okay, so why source in the folder structure? What's happening? I don't think so that there is a unique thing about it, Abdi Fatah. It's just folder structure. There's nothing. Forget about the dot. It is just to indicate the line. So under source, you can include other file folders. Do we need to merge the three CSV files provided for the project? What do you mean by merge? Merging GitHub or like? Okay. I mean, I'm not very sure about the three CSV files, but as Kerud mentioned earlier, it's better to go over all the three CSV files and to do the data analysis on all the files. I think, Kerud, am I right? So they're going to do all the analysis in both the three data, right?
Come again? I missed it.
Yeah, so Tariqwa is asking, do we need to merge the three CSV files provided for the project? So I think she's trying to ask whether we're going to do the analysis on both the three CSV files.
Of course, we need to do
Yeah.
for each one and compare the results just to come up with a recommendation. And you can show your findings on your dashboard also. So yeah, do them separately. Just have separate sheets, and you can do them. If you choose to merge them, you can, but you need to have a mechanism of tailing one from the other, because if you merge them and work on one file, it could be hard for you to tail them apart.
Yeah, I hope I hope that your question is answered. Daniel, is that possible to store in repository folder in GitHub? So yeah, one of the advantage or one of the things GitHub do is to store your file. So if you just put it on your repository, then it's stored. I hope is this session? Yeah, it is recorded and it's going to be uploaded after 4 hours. Okay. Other questions? So yeah, goodbye. Have a good day, everyone. We can stop the recording.